Okay, so we'll talk about SQL Server locking types briefly. These types of locks carry across different platforms, but they just might have different names. You've got the same functionality across them. Once you do that, as promised, I will show you how this works in Java, and then I'll end talking about the recovery models. We'll probably get out of class a little early again this week. I'm sure you guys are crying. Don't worry, next week we'll spend the whole time. All right, so one of the most common types of lock is exclusive lock. It locks a record or table, and you can control that depending on environments for your transaction. The exclusive lock means you have exclusive access to it. When you lock it, you not only can't write to it, but you can't read from it. That's a bit intensive. If you're writing an update in a record, it's a good move. Like you go back to that Shelley Jones problem. You really don't want, payroll to print out the right check as you're updating, or the wrong check as you're updating her name information. So you lock it. You don't let people read from it until you let go of the lock. Now, there's the problem. If you forget to let go of the lock, bad things happen. A slightly less controlling lock is the shared lock. It locks it for writing, but allows people to read it. So if what you're updating isn't overly crucial, or it's okay if they get a slightly different value, a shared lock's good. Moving down is an update lock. This is a lock you apply to the shared lock. So the process for the shared lock is you apply the shared lock, and then you decide, I'm going to update this thing. So then you throw an update lock on it. You're now sitting there ready for your update to run. So now your update runs. The lock changes from an update lock to an exclusive lock, which is X, when the update runs. Then when the update's done, the update lock goes away, and then you release a shared lock. So it's kind of like a lock before a lock. It's a little bit much. MySQL doesn't make this complicated. An intent lock says, I'm going to lock that. At some point today, I'm going to lock that. So it lets other queries know that I can't throw a lock on this because you might throw a lock at some point. You need stuff like that when you have massive amounts of people that are writing to it, and you have timed or some type of timing involved in retrieving information from other services. So if you go back to that credit information, imagine, if you would, you're writing to the sales database, and you're not going to update the sales database until the person's credit card passes. So you say, hey, I got an updating sale. You put an intent lock on it. Other people will know that you're about to write and will hold off on their intent lock. Your validation for the credit card comes back. You then run the shared lock and update lock, write it, release it, and then someone else can go on. Now, all this is done behind the scenes for you. The database management system will figure out the locking for you as long as you write the code right. That's a big if. If two people inadvertently open up exclusive locks on the same table at the same time, you end up with what's called deadlock. And nobody can unlock it. The database administrator has to go through and manually unlock. That doesn't happen very often. SQL Server does a really good job of protecting against this. But you can, with some effort, throw in a deadlock. I used to do it in class as an exercise, but it really wasn't that useful. You essentially have to open up two windows and run two locks almost simultaneously in SQL Server. All right, let's talk about how to do some MySQL from Java. This is the MySQL code to lock a table. What this says is lock tables is pretty clear. Customer is my table in Premier, and I'm locking for writes. You also have updates and read in MySQL. You normally don't care if you're reading from a database to lock, but you do care if you're writing. So this run, you execute that. Notice it's not execute query. It's execute. So at this point, the database is locked. Whatever your SQL is, do it now. So you're writing your update, you're inserting records, whatever. Unlock, and then you're good to go. So in your program that we write to the database, you should do this. You should lock around the write command, or that update command, or the insert command, whatever it is you used. Even though you're the only person connected to the database, it's good practice to get into. And you see it's 3 additional lines of code. 3, not 30, 3. Lock tables, whatever you want to lock, write, execute, unlock. If I'm connecting to SQL Server and I want to do a lock, that's when we go back to this transaction stuff. This transaction does my locking for me. So I can write this as SQL from Java. That sounds like fun, doesn't it? Write something that big. Going back to someone's phrase, mind melting problem, Rob's string concatenation. Yeah, this would be a big, ugly string concatenation, but you could pull it off. It's just long. All right, so let's show this working. Oh, this is MySQL. Here's customer. You recognize this. Here is hopefully stuff you recognize from your lab assignments. This is that first one we did where you just simply connected to it and ran it. I've added my lock and I've executed my lock. And now I'm doing here is I'm doing a select star. I'm not writing or anything. Now down here, I've put in a cheap artificial pause. And we can see that I have my pause before my unlock. We're going to see what this means for MySQL when I've locked this table and see what happens. All right, so I'm going to run this thing. Woohoo, welcome to Premiere. Hey, it's there. And I got my press enter and continue. I'm going to not press enter because I'm now paused here. So I'm still locked. I go over to MySQL. Oops, wrong one. Go to MySQL. Look at that. The table is blocked. MySQL says, nope, you got to lock in this thing. Nobody else can do anything until I unlock it. Yes, exactly. Access denied. But now I'm not dead. MySQL is just waiting. We actually call it blocking in the server world. It's blocking. It's waiting for this to finish. So I come over here. I'm done. And before I can even switch back, you see my select works. The reason you care, again, let's run this thing. So we see it's running. Let's pretend that instead of just a select up here, I'm doing some complicated rewriting of the data. While I'm doing some complicated rewriting of the data, my DBA comes along and does this. Actually, I'm going to arrow up to him lazy. I'm going to change customer 842 from all season to Leroy. Again, access denied. But I'm not locked out. It doesn't say no, go away. It just says wait. And then this thing finishes. Whoops, crap. Press enter. It ran. We'll run this again. And I love this about databases. There's Leroy. Leroy Jenkins. So that lock made it so that other people can't access this. Now, in reality, you're not going to put the big block here like this that I just did in a lock statement. It's going to be without these guys. So it'll lock, do its thing, unlock. That's the correct way to do it. And in actuality, this should be up here because this result is a record set that holds all the SQL. So actually, I should take this, put it here. And now it's more realistic as to how it would run. Because you would lock, run your SQL, unlock. 1, 2, 3. I just have it down there because it's cooler for my class example. You need that anytime you have multiple user access to your database. Next term, we're going to start playing with MVC, which is one of the most popular frameworks on the planet. Nearly everything uses an MVC setup, model view controller. And we're going to do this in ASP Core. We're going to build a website that reads to and from our databases. It'll automatically create the locks for us. You're going to really enjoy working with ASP.NET because it does a lot of this tedious stuff for you that you guys have been doing by hand in a couple of clicks. I think after this for you guys, it's going to work and write hundreds of lines of code for you in a couple of clicks. The book we're using is this guy. I think you can see that. Now you can see it. ASP.NET Core in Action. The book's a little dated. We're going to work with it dated and just make it work. But it's a nice book. And that's a Persian, I think it's a bishop. The Manning Press puts a variety of different Persian dignitaries on their books. If you want to understand why, they've got a description of it in the index. All right, so let's finish this up. Okay, so we've locked. All of this, locking, rollback, all depends on the recovery models. So we need to talk about this for a minute. And I have a few minutes to talk. Recovery models are a separate file from the main data. You might recall when we created databases, we wrote the MDF file in one folder and the LDF file in another folder. We did it on purpose. You know, this simulates you would actually have the MDF and the LDF on different machines or different drives. So the log data file is where the recovery model is stored. And every time you create a transaction, the initial state is put here. The recovery model you choose determines how big that log gets. When you go to pick recovery models and you're designing your databases, you have to answer yourself a question. How much data loss is acceptable? So if you think about something like a bank transaction, 0 data loss is acceptable. In a medical scenario, 0 data loss is acceptable. In a grade book, I would think 0 data loss is acceptable. But if you have a scenario where everything's recoverable, like if, you know, in a perfect world and I actually passed papers back to students and everyone of the papers, I can recover that information. So if you have a situation where you can recover your data easily or you don't care about restoring back to the beginning of the world, you get more data loss. Recovery models control how backup and restore works. I haven't done any backup or restoring with you of a database because that's, again, a DBA feature, not a programming feature. How many transactions are logged and how big that log gets. So let's look at them. Yeah, this slide. Yeah, great. AdventureWorks is restore. You're correct in that, Robert. Did I make a mistake or something? Oh, no problem. Sure. This will be available for you guys up on Blackboard, but cool to screenshot it. All right, so the simple recovery model. The log is cleared after each commit. So when we're running a simple, on all of our databases, we're running a simple recovery model. It means every time you hit commit, the log is wiped, which is why there's still just 8 meg, which is what the minimum size was we created. Unless you've done a backup, you can't restore if your data gets wiped. This is the default choice in SQL Server, MySQL, PostgreSQL. All of them use a simple recovery model. The names differ across platforms, but they're the same thing. Bulk logs, it logs any of the individual small changes you've done. Big operations are not logged. So the thought process here is if I'm doing like an import of 15,000 rows from a spreadsheet, I'm going to keep the spreadsheet. So if I have to revert back in time, I can rerun that spreadsheet. The full is everything. All of your operations are logged to disk. You can restore all the way back to the beginning of time, all the way back to the first create table, blah. And with some effort, you can use that log and just keep rolling back, rolling back, rolling back, rolling back. An example, a company a student of mine worked for, they picked up a virus. The trouble was they didn't know when they picked up the virus. And the virus infected their server. So they came in on a Saturday or Sunday, disconnected everything from the server, and just started rolling, essentially rollbacks. They did restores. And they kept restoring every day back in time until they got to a point in the server that was no longer a virus. That can be done with a full recovery log. You can go back day by day by day and restore your database until you get to the point where it's perfect. Yeah, exactly. Roll back to no virus. And it was a long process for them because they had to, run the restore, which I don't know if you ever run a restore in a server. That can take an hour. So you'd run a restore, virus check. Oh, crap. Run a restore, virus check. Run a restore, virus check. Run a restore, virus check. I believe it took them the weekend. So they probably started on a Saturday and we're done sometime Sunday night. Some viruses can get past that. It's just difficult. And they did it right. They wiped their drive prior to restoring. And even some viruses like Chernobyl wrote to the BIOS. That floored me about Chernobyl. It wrote to the BIOS. BIOS is supposed to be read-only. To set this, it's in the options of your database. Properties, options, there it is. And your choices right here. Last hour, someone asked me about collation. Latin is basically the English language. The characters that we use is considered the Latin alphabet. CI there stands for case sensitive. CS is case sensitive. So if you wanted a case sensitivity, all you have to do is change the collation, and all of a sudden, capital A is not lower A. All right, so this is about the end of my discussion today. We've looked at transactions. We've looked at rollback. You had an index assignment that's due tomorrow and transaction assignments due Thursday. This is ridiculously straightforward. I tell you everything to type and tell you what to expect and say screenshot it.